Hello, today we're going to discuss the concept in calculus known as L'Hopital's rule. It's a rather simple concept, or Bernoulli's rule, if you would call it that. And this channel has been in a bit of an identity crisis, which way we want to go, but I'm trying to get it towards elementary math and science again. However, we will, we're not going to ditch philosophy entirely. We started off trying to discuss the continuum hypothesis, and I hope to return to that at some point, but for now, we're gonna sort of delve into elementary math, and this is if you're in high school or college and you're studying L'Hopital's rule. This one's for you. We're gonna go ahead and do a little proof. It's an intuitive proof, but I think it's going to be a good one. Prove that as we move closer and closer to the origin, that y over x approaches dy over dx. Okay, it's a very important concept for calculus. It actually makes life simple, because if I want to find the derivative at the origin, I just take the derivative of y over the derivative of x, whereas, as you know, any other point, it becomes more complicated than that. You have to use, it's more of a complicated process. So let's start off with something self-evident, that delta y over delta x at any point, whether the origin or not, is going to be the same thing as y plus delta y minus y over x plus delta x minus x. Notice you have y minus y and x minus x. They cancel, leaving delta y over delta x. Now, or we can rephrase that as delta y over delta x is equal to y prime minus y over x prime minus x. Well, we're defining y prime as y plus delta y and our x as x plus delta x. So that's simple enough. And as you know, as y approaches 0 and as x, well, actually, we haven't gotten there to the part that's intuitive yet. My screen fell asleep there. Okay, fixed it. As you can probably see, as y approaches 0 and as x approaches 0, delta y over delta x approaches y prime over x prime. Well, that's very simple, because y equals 0. So just ignore y, and then x equals 0. Just ignore x. So we have delta y over delta x equals y prime over x prime. But I'm going to leave it as a limit here because we're going to need to for later on. Now, we've now arrived at the origin. Okay, so we're considering the case of the origin now. As as delta y approaches 0 and as delta x approaches 0, delta y over delta x approaches dy over dx. Now that you know, okay? But note also that y prime over x prime approaches y over x. Well, you know this, but why is this true? Well, our y prime, remember, going back here, the reason that delta y is the equivalent of y prime and delta x is the equivalent of x prime is that if you consider the frame of reference of the origin, any other value for x and y, which we denote as x prime comma y prime, whether here or down here or anywhere along the function, is going to be the same automatically as delta x, delta y, because we're considering the origin. So it would be like 0 plus delta x would be our x, and then 0 plus delta y would be our y. Or I should say our x prime, y prime. Okay. So the two become equivalent from the point of reference of the origin. So this is self-evident if you want to think about it logically, that our y prime would be the same as our delta y, and our x prime would be the same as our delta x from the origin. Screen falling asleep on me a lot. Well, this would also be self-evidently true, that as we move, as our delta y approaches 0 and as our delta x approaches 0, our new value, our y prime will approach y. In other words, it approaches 0. But more to the point, you could say our y prime approaches y and our x prime approaches x. So, this is true. This is true. So delta y over delta x approaches y prime over x prime, and y prime over x prime approaches y over x. Thus, delta y over delta x approaches y over x. But over here we see that delta y over delta x approaches dy over dx. Thus we, by a transitive logic, which is one of the earliest forms of logic you learned as a kid, right? If A equals B, then and if b equals c, then a equals c. Okay, so if this approaches this, and then this approaches this, then this approaches this, but this also approaches this. Therefore, this is going to approach this. Okay, and so by conclusion, as delta y approaches 0 and as delta x approaches 0, y over x approaches dy over dx. And if you think about it, it's very intuitive, because as you consider the origin point, our y over x, you don't really have 0 over 0, but let's say we have an imaginary infinitesimal point right above the origin somewhere along this curve, or right below it. Okay, now that may create philosophical problems, but let's just posit that it exists for now. The difference between take the y and x value of that infinitesimal point. Okay, the y over x would really be the same as the slope of the line that we would call dy dx. Okay, through the origin. Okay, so if you think about it, that's true as we approach the origin more and more. That's what we've proven when we've proven Bernoulli's rule, or popularly known as L'Hopital's rule. So that's your calculus lesson today. I thank you very much.